Welcome to the fourth video in the Day of Datomic training series. In this video, Stu Halloway will talk about the two main ways to get data out of Datomic. Stu will start by talking about querying Datomic with Datalog. From there, Stu will move on to querying Datomic using the pull API. Finally, Stu will have a look at the raw indices that underlie Datomic.
So we're going to spend a few minutes at the REPL looking at transactions. And I want to show a couple of points that were not in the slides that are useful to know. So one thing is I want to look at the return value of a transaction in a little bit more detail. So here, this is a transaction. And let me actually, we have a font size small enough that we can do this. Let me just run this dTempID db.partUser. So if I just evaluate that, we'll see at the bottom of the screen that it manufactured a DB ID that was in the user partition with some famous big number. And if I run this again, I'm just evaluating this form. If I run it again, I'll get a different one. And if I run it again, I'll get a different one. So one of the questions people asked during the lab was, when would I want to explicitly take control of this, right? If I pass in a number here, then I'm always going to get the same thing, right? I'm asking for -10 and I'm going to get -10. And passing in a number gives you a way to use the same ID more than once in the same transaction, right? If you want to have, this person be the child of that person, but also the parent of that person, you've got to use the same ID to stitch them together. If you don't care, if it's just a one-off, you don't have to pass in a number, and you can let the TempID reader assign that number. So that's what's going on with the temporary IDs. The second thing that you get into is, and this is true in other databases as well, right? You put something in the database, and having put something in the database, you want to be able to talk about it, right? But you don't have the ID. That's the whole challenge, right? Who's assigning these IDs? The database is. And so one thing you'll see is that when you run a Datomic transaction, and let me just load, I'm going to load an extra namespace here. I'm going to load Clojure's Pretty Printer so we can print out more attractive results. And I'm going to run this transaction. And what you're going to see is, and it doesn't get printed out very nicely, so let me pretty print it. So in Clojure, *1 is the last thing you evaluated. So I'm going to reprint the last thing I evaluated prettily. And what you're going to see is that the return value from a transaction has in it the database before the transaction, the database after the transaction, the data of the transaction, and the TempID mapping. This TempID mapping, there's an API function. I'm not going to go into the details of this because I'm going to show you something cooler in a second. But this TempID data structure supports calling an API call saying, well, I passed in db.partUser -10, what did it turn into? And it'll give you the actual entity ID you got back. So if you were writing a programmatic thing that was making lots of new entities and wanted to find out the IDs of the ones you got back, you could do that. Having said that, I almost never do that. And the reason is that there are really two kinds of entities in the world. Entities that have interesting identities and entities that don't. When an entity has an interesting identity, it's got an external name. And I would rather find that identity by its external name. When the entity does not have an external name, then I'm not likely to be trying to look it up. So I'm not likely to want its entity ID anyway. I'm only going to find it in the context of something else owned it, or I found it as a result of a query. So what I'm going to do now is I'm going to connect instead to the MusicBrainz database. And I have to remind myself what URL I'm using. MBrainz 1968 to 1973. So I'll connect to that database. And now I want to talk about an entity in this database. So I'm going to say, let's see. I'm going to grab the database value at a point in time. And then I'm going to pull from that database value all the attributes of a particular entity. Now, if I just passed in entity 42, right, This is life when you have to work with numbers, right? I'm hypothesizing that there's some entity 42, and the star here in a pull expression says, give me back everything about 42. And 42 turns out to be, some schema attribute. But what if I wanted to know everything about Paul McCartney? So here's a place where things are kind of no fun, potentially, because I could obviously, and we're going to do query, that's our next module. I could, if I had query in hand, I could write a query that says go and do a query for Paul McCartney. But a query is kind of overkill for just naming a thing. What I'd really like to do is live in a world where I say, you know what, I don't care that Paul McCartney's ID is 27,463,000, whatever it is, in the database. I just want to call Paul McCartney, Paul McCartney. And the way you can do that is with what's called a lookup ref. So I can say, I want the artist whose name is Paul McCartney. This gets me out of the business of ever having to talk in terms of entity IDs. And this data structure, this list that has an attribute name followed by an attribute value, is called a lookup ref. And anywhere in Datomic, typically, that you can pass an entity ID, you can also pass a lookup ref. And that tells Datomic, hey, go look this thing up by its key. What do you suppose the requirement is on the artist name attribute to make this work? What does it have to be? It has to be indexable and indexed, and even more than that, unique. If it wasn't unique, I'd get back, there could be more than one Paul McCartney. So let's give that a spin. Hopefully I actually connected to the right database. Attribute value is not unique. Artist name is not unique. All right, let me find a unique attribute that I can look up. Of course, the thing that stinks about this database is that in the MusicBrainz database, it's actually, they actually have GUIDs for everything. So it doesn't actually help you that much. You get out of the business of working with a number and get into the business of working with a UUID. So maybe this isn't a great example. Let me see if country name. Yeah, country name will work. So let's do country name. Now, in the case of country name Bangladesh, I have an even better way of getting to that. What can I do? Remember we said before, we've actually given programmatic names to all the countries. So I could literally, there's 3 different ways to refer to an entity in Datomic. We'll just put all 3 of them beside each other here. I could refer to it by its ID. If I could type, I could refer to it by its ID. Right, that's going to give me Bangladesh. If I refer to it by its lookup ref, that lets me look it up by a unique attribute. Or I can refer to it, if it has a programmatic name, I can refer to it directly by its programmatic name. Yeah, and if I spell it wrong, I'm not going to get back anything. Better. Right. So by far of the 3 of these, my suspicion is the one you're going to use most often is lookup refs. Right? Because lookup refs says I have a uniquely named thing that I know about. Having an ident is not going to be that common in regular programmatic use because you're not going to give everything a programmatic name. Remember, that's an in-memory cache of stuff. That's not really for the database. That's for things like the schema. And then I'm not going to be passing around, sometimes I will be passing around those big numbers if I got an entity attribute, an entity ID as a result of some other query. Make sense? Any questions about transactions before we move on? All right. All right, switching back to mirrored displays. And we are going to talk about querying Datomic. So there are 4 ways to get data out of Datomic. Datalog, which is a logic-based query language, declarative. Pull, which is a navigation language, also declarative. Entities, which is a lazy navigation, right? This says I'm going to have something and then I'll lazily ask for something else and lazily ask for something else. And then you can ask for the raw indexes. By far the most interesting of these for finding out information out of your data is Datalog, and the most interesting one for sort of structuring those results is pull. So the majority of your use I would expect to be a combination of Datalog plus pull. So why Datalog? We thought when we made Datomic that if we had Datomic be different from every other database in every possible way, that would just be amusing for people trying to learn how to use it. So instead of SQL, we had it use Datalog. That is not the reason. So Datalog is powerful in the sense that it is similar to the relational algebra or the relational calculus in SQL, or not really in SQL, but that inspires SQL. It's a logic-based language, and it was devised, Datalog was devised for database queries. Back in the day, there was a brief flurry of people who were going to use Prolog to query databases. And what they discovered is that Prolog has no guaranteed termination. And so you started having to put cuts everywhere in your Prolog programs, and they didn't feel very declarative anymore. And so Datalog was devised as a cousin of Prolog, but that would have the characteristic of guaranteed termination. Then the question is, if Datalog is so cool, why didn't relational databases use it? And the reason is that the most straightforward way to represent Datalog is positionally. Right? So you're going to talk about the things in a Datalog query in terms of their position in a tuple. Well, imagine a SQL database where you have something that has 40 columns. And so you're going to have a tuple where you're matching something in the 36th position. What human reader is going to do well making queries that way? Now, imagine Datomic. What's the smallest possible tuple in Datomic? A 5 tuple. What's the largest possible tuple in Datomic? A 5 tuple. What is the set of possible different orders in which things can show up in that tuple? 1. Right? So it turns out that having a positional single universal schema tuple is really a good fit for a positional pattern matching query language. So let's do it. We're going to work with an example database. For laziness, our example database is going to leave out the transaction and the added columns. So I'm only going to show you the triple, right? The first 3 parts of the data for now. So we're going to have entity 42, whose email is jdo@example.com. Entity 43, whose email is jane@example.com. Entity 42 has orders, both 107 and 141. So that's a cardinality mini attribute. We're going to match that then with a data pattern. A data pattern is a list where that list both constrains results and binds variables. The constraints come from constants. So here we have a constant in attribute position. Right, we're saying I only want to find the things that are emails. So I don't want to find orders or anything else. And then the entity and the value position are variables. So that says bind customer to all the E's that have emails, bind email to the email values. So if you pit that pattern against our example database, here's what's going to happen. You're going to bind 42 and JDO and 43 and Jane, and you're going to ignore the rest of the database because email says I only want emails. These constants and variables can appear anywhere. So now we're going to have a more constrained data pattern. Notice this data pattern, the first data pattern we saw had 2 variables and 1 constant. This one has 2 constants and a single variable. So find 42's email. That's going to find an exact single thing. Right? Find me the email associated with 42. Or, well, this is starting to look interesting. I can say, what attributes does customer 42 have? So notice that now my pattern is truncated. I'm not referring to entity attribute value. I'm only referring to entity attribute. Another thing that being positional does is it allows you to say, you know what, we're going to leave off the trailing components we don't care about. So all along I've been leaving off what? Transaction and operation, right? Add or retract. Now I'm leaving off value as well. So this says, tell me what attributes 42 has. That's going to return a set with how many things in it? Think carefully. A set with how many things in it? Set's the key word. 2, right? Because orders is repeated. You're not going to see that twice. Now, you can also have variables in both the attribute and value position. This says, tell me everything about 42. Everything we know immediately about 42. So that's going to find email, JDO, orders 107, orders 141. These data patterns are then plugged into a where clause. So right now we're going to show a where clause with one data pattern, but in a minute this where clause can have more. And then combined with a find clause that says which variable to return. So this particular query pattern is saying find all the things in the system that have emails and assign them to the variable customer, and then return that variable customer. So this is a little bit like select customer ID from email. Right? If you wanted to just do the little SQL thesaurus in your head, this is select customer ID from email. And then here's where it gets cool. Anytime a variable appears in more than one data pattern, it causes a join. So this says find all those things in the system that have emails and call them customer, but only if they also have orders. And this is where it starts to crush SQL from a sort of ease of reading, because you don't see all this like, I have to go to this table, I have to go to that table, I have to join on this key, I have to join on that key. Plugging that into the API looks like this. I'm showing here the example, the API in Java. The only difference in Clojure is that the parentheses are in different places and all the commas and semicolons go away. Right? So it's not different. This is saying find customer where customer has an ID and customers has orders in the database. So the name of the query function is Q. Query then takes a query pattern and an input. Sometimes you have more than one input. The most easy case to imagine getting into here is you want to do a parameterized query. So with a parameterized query, you're typically going to have a database input and also some parameter that's bound by the user when they perform the query. The way that's going to look in Datomic's data log is that database inputs are prefixed with a $. $sign means database. Databases are where the money is. And then inputs that are bound on input are just variables. So here I'm saying look in the database for a particular email. And this is what that's going to look like in the full context of a query. So notice now that we have inputs. We have multiple inputs. And the way that you read this is that the in clause says there are going to be a bunch of things at the end of this query call that you should bind in order. So $database gets bound to the DB argument. $email gets bound to jdoexample.com. And then in the query, we're now well, it just got a little bit interesting. Our data pattern is now not entity attribute value anymore. What's at the beginning of that data pattern? Database entity attribute value. Dun, 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 dun.
Can you show me where you're pointing? Because there's like, you're referring to email and there's 3 emails. I don't know where you're talking about.
So here, let's go back through this. So this in clause says this database binds to the first argument. The second thing there binds to the second argument. And it's all just positional. It's all just this order drives this order, so you know what order to pass things in. And then this crazy thing happens. Before we were talking about databases and we didn't even say anything. Now we're being explicit and saying, I'm looking in a particular database to find this. It's idiomatic to make the database name really short, because a large number of queries are only against one database. In that case, it's idiomatic to name the database $sign, and in fact, it's idiomatic to leave it out entirely from data patterns. If you leave the database out from a data pattern, it will assume that the database name is $sign. If you leave out the input, the in clause entirely, it will name the database $sign and expect it as the only argument. So what does this let you do? This allows you to find things in the database that exactly match something. Right? You now have the power with this data log query language to exactly match things. So you can look up jdo@example.com, and you can do joins. So you could say find this and join to that and join to the other thing. But we need more than that. We need the ability to do things like predicates. So I want to say find only the prices that are greater than 50. So this is a predicate pattern. This appears in a where clause. And this says, given that we have a bunch of prices, I only want the ones that 50 is less than. And so that might be used in a query like this. This says, find the items in the system that have an item price of price, then limit them to only the ones whose price is greater than 50, and then notice now that now that we have more than one variable in the where clause, we might choose not to return all the variables. In particular, we might choose to say, I only want to find the item. Right? I don't care about the price of the expensive things. I only want to know which things are the expensive things. You can also call arbitrary functions. So imagine that we had a system where we were going to estimate the shipping cost. So we've got an online shopping cart. And so with that online shopping cart, we're going to say, given a zip code and a weight, we're going to estimate the cost to ship something to you. Well, this is a function, so it has two inputs and an output. Right? Zip and weight are bound inputs. This function will only fire in your query if the query has already found zips and weights. If the query doesn't have any other clauses that can find zips and weights, this query will throw an exception. It will say, you are trying to ask me to call a function on stuff that I don't have any way to bind. And then the function will return cost. So now we can put this all together. And actually, before we get to this slide, let me give you the motivating example. I like jerky. It's tasty. It's full of protein. It's full of salt. What's not to like? I order some jerky from a boutique place in Montana, Buffalo Jerky. And I'm on an online store, and the Buffalo Jerky, you can already see where this is going if you're a jerky aficionado. The jerky costs $11, but shipping from Montana to Chapel Hill, North Carolina, where I look, costs $14.99. And that makes me mad. Because I wouldn't have cared if they told me the jerky was super awesome and the jerky was $30 and shipping was free. Even though that's more, you all saw that that's more money, right? 11 plus 15 would have been 26. I'm mad at 26, I would have been happy with 30. Human psychology. So I call the company and I complain and I say, it really makes me angry when you sell me something and the shipping is more than the thing. And so they say, well, we should go look at our system and see how often that can happen. Well, what would you have to know? If you wanted to ask that question of your online shopping system, what would you have to know? You'd have to know who your customers were. You'd have to know where they lived. You'd have to know what they might buy, how much the things they might buy might weigh, how much those things might cost, and then you'd have to have some function that said, like this shipping function, some function that said, given a zip code and a weight for something, how much is it going to cost me to send it there? So here is putting that all together in a single Datomic query. So what we're saying here is, I want to find all the customer product combinations where the shipping cost is going to be larger than the product cost. Well, I certainly have to find all the customers and their zip codes. The way we've modeled customers in this system, customers have addresses, addresses have zip codes. So that's going to be a join. So you'll notice here that question mark address appears in two places. So that's a join from customers to their addresses and then addresses to their zips. So at this point in processing the query, we've now bound customer, address, and zip. And I need to know all the products and their weights and prices. Product appears twice, so this binds together weights and prices for products. And then I'm going to call this shipping estimate function, which takes a zip code and a weight and returns a ship cost. And I've talked about called this estimate function, but I haven't really talked about where these functions come from. They are any plain old JVM function. Right? So in Clojure, you write them as a function. In Java, you write them as a static method. Right? So shipping/estimate calls this function. And then I'm going to say constrain this query result such that the price has to be less than or equal to the shipping cost. And then I return the customer and product pairs. Now, if you don't think Datalog is cool, your homework assignment is to write this in SQL. And remember that this has the power that SQL has, right? This is not like a crappy trade-off where I have to map reduce to get information back out of my system. This is a logic-based query language, but it has a ton of expressivity. So what we're going to do now is I'm going to sit down and go through some of the sample queries. All right. So in the top window here, we have the MusicBrainz sample queries. So I'm going to be working through these. I'm going to get rid of the comments as we go because they're just in our way. So I will connect to the database, get back the database value, I'm going to set the print length to 250 just in case I try to print something really big. If I try to print something that has 1,000,000 things in it, I don't really want to wait for the REPL to finish printing it. And now we can start running some queries and look at how these work. So this says, find me the title in the database and the artist name where this artist, some artist A has that artist name, where there is some track who has that artist as the musician, and then that track name has some title. So I will run that, and we're going to get back and actually we can pretty print it, or we could if we had actually put in the, they called it pprint. Let's call that PP is the universal abbreviation for pretty print. So try that again. And we'll pretty print it so we can see that I still didn't get it. Oh. Yeah, nobody. Well, fine. I'll just say preprint then, since we did that. That didn't help very much. Oh, right. All right, never mind. Try that. All right, so there they all are. So these are all the titles that come back when we do this query on John Lennon. Now I want to stay on this query for a couple of minutes and show you a few other things. So I'm really going to kind of blow this out, and then we'll go quickly through the other ones. So one of the interesting things that happens when you're in Datomic is that you're not hugely incentivized to get back all of the details in a single query. Because notice that when I'm querying, I'm not querying against the connection. Right? The connection is a scarce resource. It's a thing that can change out from under me over time. But this database is an immutable value. It's never going to change. So that changes the way you think about queries, because you might choose to do things in a more staged way. Right? Return me some stuff, think about it, go back and get the rest of the stuff later or whatever. And in particular, it often leads to a style where people just say, you know what, I only want the entity IDs. Given the entity IDs, I could always go back and get the other stuff. Right? So those are the entity IDs. The other thing, then I'll show you about query, is that query always works in terms of a collection shape that could match a relation. Right? So a relation is a set of tuples. And so notice that the query results that come back look like a collection of collections. One of the first things that happens when you have this collection of collections thing coming back all the time is that when you're actually ready to consume it, you want to unwrap that a little bit. Right? That form is the most generic. It's suitable, for example, for piping the results from one query back into another. Right? The shape of a query result is actually another database that could be piped into another query. Right? Because what is a database? It's a set of tuples. What's a query result? It's a set of tuples. But you get tired of that, and we'd like to have a declarative way to pull that out. So what you can say is there are different find bindings. This find binding, t ... inside of square brackets, says I want to get back the collection unwrapped. So now I'm going to get these back entirely unwrapped. So the relation shape is most general. If you're writing a program to be consumed by another program, you always want to stay with relation shape. But when you get to the very edge, when you're giving it back to a human or drawing it on a screen or whatever, you often want to take control of your shape. So there are a bunch of different patterns that can be used right here that can control the shape returned. So another one, which would be inappropriate to use here, but I will show it to you anyway. This one says, I know the query returns only one thing. Right? The period's sort of like, and I'm finished. That's a lie here, so it's going to actually have kind of a nonsensical result. It's going to have even more of a nonsensical result because I put the call to seek in it. Right? That's just going to return the one thing. The other thing you can do is, I showed you before a couple of examples of using pull, where I could say, take the database and some pattern that says what do I want to pull out of the database, and then some entity ID. So I could say, give me everything about that track, and that's going to give me all the different attributes of that track. Or I could say, give me specific things about that track. So I could say, give me the track duration. So the asterisk is give me everything, but I just want the track duration and the track name. That's just going to give me back those pieces. So again, this is an example of things being decomposed. The query API is a logic API that's primarily about locating entities. The pull API is a declarative API that's primarily about navigating from entities to specific information that can be reached by navigation, as opposed to that can be reached by logic and by join. Of course, these things are pretty much chocolate and peanut butter. And we all know that when you mix chocolate and peanut butter, that everything gets better. So what you can also do is combine them and say, I'm going to pull out of the database the track duration and the track name of T. And I always get these expressions in the wrong order. So let me flip this around. And there you go. So if you just want to find entities, you can use query. If you just want to navigate around from entities, you can pull. If you want to do both in one step, you can use a pull expression inside the result of a query. Or you can break this apart, spread it out over time. Because the thing you're working with is immutable, you can kind of think about this for a while and come back. Right? It's not going anywhere. It's not going to change out from under you. Yes?
Is there a particular reason in pull the first pass of DB? In filter, in query, it's like you pass it last.
So in Clojure, it's idiomatic that when you have a collection or a seek, that thing comes last. And if you have a thing that's the primary thing that the job is about, it comes first. So the primary job of query is the query expression, not the data that it works against, because there can be more than one kind of data. So it doesn't make sense to have the database be the first object. In particular, a query can exist without a database. Right? Those are kind of weird query expressions, but you can write some. So the query expression is the primary thing. But in general, you're going to see Clojure using positionality to have the subject of a thing be the first argument, or the collection subject of a thing be the last argument. And those are the kind of guiding rules on what happens where. So we will find a few more elaborate queries. So here is all the titles, albums, and years. And you can see there's quite a bit of joining going on here. We're taking John Lennon, which is bound as artist name. Artist name will lead us to A. A will lead us to T. T will lead us to the track title. T will lead us to the medium. The medium will lead us to the release, which will lead us to the album and the album year. And again, we get a long set of results. Ugh. There.
Pull API, when I get DB ID in lookup graph from,
Well, DBID is not DBID is not an attribute, right? DBID is a special key for naming the entity ID. If you already have the entity ID, you don't need to put it in a lookup ref. You can just pass in that thing. You can pass in that thing directly, right? So it doesn't really make sense to do that. So the other thing I will show you briefly, although I'm not going to do it here because I don't actually have the rules installed on the system, is that Datalog has a mechanism called rules. So notice that this where clause is no longer referring to data patterns. It seems to be calling functions called track search and track info. Rules are a mechanism for code reuse in data patterns. And so those are written somewhere else, right? Somewhere else in the system, I've written the definition of track search and the definition of track info. And what that lets me do is maybe take a clump of 8 or 9 different clauses that all add up to some semantic. Right? If this is true and this is true and this is true and this is true and that's true, I'm going to call it track search. And it lets me write reusable chunks of code. This is equivalent in the SQL world to views, where you can create a view on a table that's like a reusable interpretation, on top of stuff that's already there. And so you're going to see that in the query patterns where you see this % sign, which names or set of rules that get passed in. And these queries get more elaborate and allow you to do things like these collab rules are actually recursive rules. So they allow you to start with a particular place and then do a recursive search.
Those rules are residing locally, not actually in the database, right?
That's correct. The rules. So there's an important thing to perhaps say again and again here. We're going to say this a little bit later when we talk about the time model of Datomic and the operational model. But where do these queries run in a Datomic system? They run inside the address space of your program. Right? These queries are not being sent to a server at all. Right? The call to the server was, go back and look, that happened in one distinguished place, right? And even that didn't actually go to the server. Right? Well, actually, there is no call to the server here. I guess connect is a call to the server. But with the connection in hand, you already have a pointer to the top of the database. And given that pointer, because it's immutable, you can lazily fetch whatever pieces you need as you need them. So all of these queries are actually taking place inside your own process address space without RPC. And this is kind of a canonical win for immutable data, because if your query, the data you need to answer your queries can fit in cache in your local process, you will have memory speed queries. Whereas a traditional database has RPC speed queries, right? It's inevitable. No matter how fast a query can go, you have to go over to the asking place to ask it. Right? In Datomic, the asking place is inside your process. And this is a reason, right? With reason we don't call it client server or something else. It's called a peer model, right? Because all the peers in the system have the entire database, lazily and virtually, mapped into their address space as needed. And so all this stuff we're doing here is talking to that database in our own process. I could turn off the transactor. Maybe I should do that. So I'm going to go, just to drive this home, and if I can find the transactor. So here's my transactor. I'm going to shut off the transactor. I'm going to prove to you that the transactor is shut off by doing something like, actually I can just jump to I'm going to try to transact something into the transactor. And what we're going to see hey, the transactor is not available. Right? I can't do writes on the system right now because I killed the process that's in charge of writes. Now I'm going to go back to Music Brains, and I'm going to say, tell me all that stuff about John Lennon again, please. No problem. Right? So it really is, one of the interesting things about building a system that's fundamentally simple is it actually breaks questions that people want to ask. So people are going to walk up to me and say, when is Datomic available? And I have to say, well, the first thing is available for what? Right? If you keep the reading processes up, they're available for reads regardless of what the writing process is doing. If the reading processors are down, but somebody else knows, a particular reading process is down, but somebody else is talking to the writing process, they could still be writing. Yes?
So it's not talking to the transactor, but it's still talking to the storage, right?
Is it?
I'm
So the question was, wait a minute, it's not talking to the transactor, but it's still talking to the storage. To which I responded with my mysterious, is it? Right? Is it talking to storage? Well, now, there's one of the things that's operationally subtle is that a real Datomic install has at least 3 processes. Storage, a transactor, and a peer. But a real Datomic install has at least 6 processes. Right? Let's say at least 7 processes, right? 3 processes for storage because you want to have some sort of vote-based availability. 2 processes for the transactor because you want to have a failover guy who's ready to jump in if the transactor fails. And 2 processes for peers because you want to be highly available, right? If one of the peers dies, you want to be able to have the other peer take requests. However, I am running the transactor on my laptop right now in dev mode. So dev mode is not for use right? Not for reals like that, right? It's much more sort of, proof of concept. I'm playing around. I'm just doing dev work. Or I have, low availability and redundancy and reliability requirements, because in dev mode, the transactor actually has storage embedded in the same process. That's the only protocol that works that way. All the other protocols in Datomic that store things anywhere store things into a separate storage service. But this is a development convenience, so you don't have to launch another storage service just to play around with Datomic and kick the tires. So when I turned off the transactor, I also killed storage, and it's still working.
So this is a local cache,
Yes.
but you don't actually want to have your whole database in cache.
Why not?
I mean, because it doesn't fit.
So if you ask for Yoko Ono, will it work or not?
Now we're getting somewhere. Yeah, so we didn't get that. We didn't get that one back. So that's right. It's not guaranteed to be available for reads if storage is down, but it might be available for reads for storage down for the things that are in the cache. We'll talk about this more later. We're really sort of jumping into the next talk here. So the other thing I want to talk about before we break for the lab is that you are not aware of indexes when you do queries or when you do pull, right? You didn't say, indexes are like an imperative, like go over here and walk down here kind of thing. But I want to talk about what's under the covers, right? If you want to do something that's like key value lookup in Datomic, right? Given the email address Stu at Cognitect, who is the Stu entity, then you want to have an index that's attribute leading, right? Because K would be the attribute, right? The key would be the attribute. Datomic has an attribute leading index. It's called AVET. If you want to look up all the information about an entity, like a row in a traditional SQL database, then you want to have an entity leading sort, right? Sorted first by entity, so everything about Stu is all in one place. That's EAVT. If you wanted to have an analytics style column database, then you want to have all the attribute values that are the same together. So you want to be attribute leading, but you don't necessarily care about sorting the values. Right? You don't necessarily need those, so you might be happy to group the entities together. That's AEVT. That would let you do something like process all the emails and send something to all of them without touching any other part of the database. Documents are really kind of a mess as a modeling construct, because documents mean you sort of gave up. Right? You just said, well, I'm just going to put a bunch of stuff together and hope people want that later. The great thing about Datomic is you can assemble documents dynamically. Right? You could say, I want to think of my database as if information about people and their orders was a document. Well, then do a query that finds people and a pull that pulls their orders. Now that's a document. Now what happens if you put people and their orders as a document in a document store, and then you want to do something that spans all the orders? You got to either make a whole new thing, or do some sort of special gyration and make an index on that thing, or you have to do something, right, to make that work, and this just falls out. Or you might want to have a graph style thing where you say, given a musician, find the tracks, and then find those tracks others musicians, and so forth. And Datomic supports that by having a reverse index, VAET, anytime there's a reference. And this is what says, and this was a question at one of the breaks, I only have to have one attribute to have bidirectional navigation, because EAVT will take me one way, VAET will take me the other way. And what this really does is it makes your database more agile, because you do not bake in what questions you want to ask when you put your data in. Picking any one of these other styles makes asking some questions privileged and other questions hard. And actually, key value and document are just not very good for answering questions anyway. Both key value and document are kind of leaving you with, you've got to do all the work to ask questions somewhere else, right? Because we haven't done it. Rows and columns and graphs make asking certain kinds of questions great, but then other kinds of questions are hard. In fairness, the one thing that Datomic does is it stores stuff redundantly a lot of different ways. So it uses more storage. I'm okay with that. Storage is not that expensive these days. Yes?
So if I remember well, the VAET is only created if we put the DB index true.
Now that's AVET, KV, that one. The one that lets you look things up by value.
Okay.
VAET is always created. And as I said earlier, my recommendation is to always set DB index to true, and we may actually change Datomic to automatically set it to true in all cases in a future release. So I would recommend that you live in a world where all of these are available, and that's already true if you set DB index true.
Is that one like the T is first?
I want to have T first. That's in the next talk. So there's another index where T is first, and that's in the next talk, but it's different from these. So what are we going to do for this lab? I've already kind of done exploring the MusicBrainz data with the Query API and a little bit of exploring it with the Pull API. What I would recommend that you do is query some of your own data. So take a look at the examples for query and for pull at docs.datomic.com, the ones that are linked here. Take a look at those examples and then translate, and you're going to have, you have simple data models relatively. Translate those queries to query your own data. You can do this at the REPL, so you can run bin/REPL from Datomic, or you can run line REPL from the Day of Datomic project, or you don't have to launch a process at all. You can go type these queries in to the console. Right? There's a little box on the console on the right where you can type in your queries. So do that either way, and we will have a relatively short amount of time for the lab here and a break, maybe 40 minutes, and then we will get started again. Thank you.